Okay guys, in this video we are going to look at an mp4 file, how to read an mp4 file and how an mp4 file is structured. That is the purpose of this video. I know that we are using mp4 files everywhere online when we make video calls, watching streaming videos. All of those are mp4 file or files that are very similar to mp4, but here we're going to look at how an mp4 file is basically structured and how you will write an application that reads an mp4 file. An mp4 file is basically composed of objects which are normally and more often referred to as atoms, and these objects, as per the standard, they are either content objects or they are container objects. So what's the difference between the two? The content objects, it's those objects that have the actual content within them, while the container object is those objects that contain other objects within them, and these objects are arranged in a manner that is more similar to that of a family tree. That means there are objects that are at the top of the hierarchy, and then there are objects within other objects. You go down the hierarchy until you get to objects that actually contain the content, and content will relate to things like the duration of this video, when it was shot, the location to which it was shot from, and many other sort of things, the samples where they are contained, when last this file was modified, when it was created, the camera that was used, the mic that was used if there's an audio. So it's information that is like that. If you can look at the media players, they are able to display to you that information. It's because they know how to read an mp4 file. So here I am going to show you how to read an mp4 file, and obviously I cannot be able to show you everything about a mp4 file, but the basic things, the basic small things that I am going to show you today, I believe that they would help a lot in understanding the mp4 file. Now what I've learned is that you've got to be a very patient person. It's 4 years now working on studying like an mp4 file, how it works and all of that, everything about it, and how it is structured, and how these files that actually collect information and write it into an mp4 file do collect all of this information. Without now wasting any time, let's jump in and write something that is of practical. So here we're going to have a method that is basically going to read the first collection of these objects, that is objects that are found directly into the file, not objects that are found within other objects. So here we're just going to read the ones that are directly on the file. I don't know if you get what I'm saying. So but let's go and do this. Let's say private. We don't need it to return anything. I'm going to see let's say get let's say boxes, first level boxes, get first level boxes of then you're gonna specify the file that we're gonna say file name, or the full path. Yeah, the full path of what am I doing now? So here you're gonna specify the full path. So we have this method. So what do we do now? The first thing that we're going to do is to open that file and then read all the bytes of that file, and then start reading the actual boxes the way they are structured. So how do we open a file? We have we're going to say, let's do this. Let's use a using statement. Crap. Using statement. So we're gonna have a file that is called variable. We're going to say file stream. Let's say path due path dot get no, what am I doing? So here we need to open a stream. We can say new file stream, then we need the file name. The file name should be actually a full name, not just a file name. And then here the next thing is we're gonna say file mode dot open or create. Does that make sense? Yeah, cool. So now we have a stream. So now we need to read all of the bytes out of that stream. Let me see if we are going to find a method that is going to allow us. I'll call these file bytes because that is what we want. We want to work with the bytes that are found in that file, and there is file stream dot read. Cool. Let's do this. This is how you say file bytes is equals to new. Gonna need a array of bytes, so how big it is should be file name dot okay, let's do this. What we're gonna do is file dot read file bytes offset up until file stream dot, there should be length here. How big is this thing? Dot length. Cool. I'll tell you, we'll do it. This is how you learn in life. Make mistakes. So now we need, so this method needs you to offer it an int, while length gives us a long. So length returns a long while we are expecting it to be an int. Hey, but this one is not safe. Yeah, but okay, that's fine. So now we have all the bytes inside the file bytes variable. So that's our file. That's where these bytes are. So now we say there are objects that are on the first level of the family tree. Ne? So there are boxes that are on the file directly, and then there are boxes within these files that are found directly on the file. So we know what boxes are on the first level. One of those boxes is F-type, which is a content box, and we actually get information such as for example, things like what was used to encode this file. If there's an audio, like the encoding that was used to encode the file here, the type of file and what specification are supported, or what specification can be able to actually play this file. So the first box here, as the per the standard, the ISO standard, media standard, the first box should be F type. And the way these boxes are named, they are given a name, and that name is composed of four characters. It cannot be more than that. It has to be four. The standard says it has to be four. It has to be four characters. If it's 3 characters, and you have to add a space at the end of that name, but it should be only 4 byte. There's only 4 byte that you will have to allocate to store the name of the box. So the second thing, it's the size of this box. Then you also have to allocate 4 byte to store the size of the box. But the size of the box should only be able to determine it once you have collected all the data, all the data that is going to be stored within that box. Does that make sense? But you are not the one who will be collecting the data. It's actually an application that will be performing the encoding. Does that make sense? You will just read this data. You will just be able to tell, because the size is going to be able to help you. It's going to help you to be able to move from one box to the next, from one box to the next. So let me not waste time. Let me do this. Let me do this. And how do we do this? We say while, because we will be going through this array of bytes. So while file bytes dot length is greater than let's say byte offset. That means this tells us where we are in this file. This will tell us where we are as we are reading this. We'll have byte offset, which it will begin from 0. Yeah. So what we're going to do, we're going to read 4 byte, and then when you read the 4 byte, we get the size of the box. We read another 4 byte, and after reading that 4 byte, we get the size of that box. And then we add the offset to the size of the box to get to the next box. We read 4 byte, it's the size. 4 byte, it's the name. We add the offset to the size of the current box to get to the next box. So we will do that until we get to the end. Until we get to the end of the file. I don't know if you understand this, but you will see it. So byte offset tells us where we are on this series of array. It tells us the offset where we are, the byte offset where we are on the file. So we begin from 0, and then when we are on 0, the first thing that we do, we read 4 bytes. So we're going to have a variable that is going to store these 4 bytes, these bytes in 4. We're going to say byte, an array of 4, and then the other one is going to store the name bytes. These are the bytes that contain the name. You said it's 4 characters, né? So you have an array of 4 byte. Cool. So then we're gonna also have, or we are going to also have the size bytes. The size bytes that are going to contain for the size. So here we're going to store the bytes that gives us the size of the current box. Does that make sense? So now let's go. We read 4 bytes out of file bytes. We get the size of the box. Yeah, we begin by the size. We read the next 4 bytes, we get the name of that box. Does that make sense? We know, okay, we are reading this box and its size is 15 bytes. So we know now, we check the offset. Okay, offset is, we add offset plus the current box's size to get to the next box. Does that make sense? So now let's go. We say fine, we're going to read file bytes. Okay, file byte, if you look at it, it's an array of bytes. So we need to create a stream. We're going to create a memory stream here. Let's using again. Let's use using again for this memory stream. So we say memory stream. When I have this, because we say new memory memory stream. Yeah, we create it from file bytes. So we have a memory stream so that we read this thing properly. So we're going to read, we're going to say memory stream dot read. We read how many bytes? We read name. We read into name bytes. We begin by the size. Actually, it should be size. Size bytes. Begin from 0. Size bytes dot length. Cool. So, and then we go to memory stream dot read. Remember, as you read, the position of the offset of this stream, of the memory stream, is moved by the number of bytes that you have read. Does that make sense? So here we are reading 4 bytes. So that means automatically the position of the memory stream now have been moved to 4 bytes. 4 bytes. So that means when we do the next read, we will start at 4 bytes. Let's do this. Oh my god. Name byte, and then we say 0, and then we're gonna say, and then we dot length. So now these two read will give us the byte, the size and the name of this current box that we are reading. Does that make sense? Cool. Cool. So now we need to, in order to actually know the size, because here we have a series of bytes, we need to reverse this, because this is stored in a reverse order. We need to reverse those bytes that are in size bytes, and then convert them into an integer to actually determine or define the actual size of this box. And then we're gonna have to go or loop through the name bytes to actually put together those characters and convert each byte within those the name bytes, convert each character and put them together to actually have the name of the current box. Does that make sense? Cool. Now you have a let's start with the name byte. So now we're going to declare a variable int and say size box. We're going to say box size is equals to bit converter dot to int size bytes dot reverse start index. Cool. Let's do this. You need to reverse them first. Reverse those size, and then go to size bytes. Cool. So now we have a box size after that. And then we go through this one. We say name bytes dot length, the dot length, we say, let's declare this variable here and say string box name. Box name, it begins as an empty string. We want it to begin as an empty string, and then we'll be concatenating this string, and then we'll see box name is equals to string dot format okay, so we need to convert and say we say name byte, the first byte, we need to convert it to char. There's a method that we use. What's the name of that method? Character. See, okay, let's say bit converter dot to char. There we go. And then we specify the byte that we want to convert to a character. Let's see, start index. Wait a minute. Returns a Unicode character converted from 2 bytes. The character found by 2 bytes beginning at, okay. I know there's a, do we get it? Say converter dot or Unicode not Unicode, this should be, because it's been a long time, a very long time not working with these things, so I kind of forget how I used to convert them, but I will figure it out just now. But we need to convert this, each byte there, to a character, to an ASCII character. Text encoding. Cool. Now we were here, guys. This is the class that I was looking for. It's found on system. It's found on the system namespace, and it defines a method called toChar that accepts as its parameter the byte that you want to convert to a character. So we'll be calling this method concatenating those characters to box name to create one name which will be composed of 4 characters. Does that make sense? So now, after all of this, we now have the size of the current box and the name of the current box. So now we are going to come back here to do the same, but what we need to do is to move the stream, is to move the position of the stream, because we have to go to the next box. I don't know if I do make sense. So where do we do that? How do we do that? We should add to byte offset the size of the current box. Byte offset plus the size of the current box, which is box size. Box size. So now when it comes to read, it's going to read from byte offset, which is plus the current box. If the current box was 15 bytes, for example, from the beginning, byte offset is 0. It's going to add 15 byte, and then on the next loop, it's going to start reading from 15 byte. Read from 15 byte, it read the size of that next box, and then it read another 4 bytes to get the name of that box, and then it does the same. It's gonna do this until byte offset is equal to length, and that will mean that we are now at the end of that file. Does that make sense? We will test that just now. Specify an mp4 file and then see. And the other thing is to print this just for testing purposes. We're going to print this to console dot write line current box box name, and then print another one that gives us we should start with this one. And then make a tab and then print the line so that the next one we print it on the next line. Say current box size we'll say box name here. Cool. Right? So let's actually call this method and give to an mp4 file. Gonna test by adding a new folder, say mp4 file. I'll copy a file to that file. Copy one of my courses here into this file. Cool. We'll take the full path, just to test if it does what we wanted. So that's my mp4 file. It should be static. Because we are calling it inside a static method. It should be static. So I'll put a there and run this code. Let's go. There we go. Let's see. Okay. Okay. Reverse. How big it is. Oh, something is not right. It can't be like that. Let's check the name. Yeah. I think we are fumbling. We are butchering the size here. Something is not right with the size. Let's look what's the problem. The size cannot be big like that. Oh, yeah. We need to say array dot reverse and then supply size bytes, and then it reverses size bytes. Yeah, that's what we needed to do. Let's start it again. Check the size. 24, it makes sense. So the offset will begin at 24. Okay, let's read the second one and see. It is also 24. See what box is this. It's the F type again. Oh, ooh. I know exactly what we have done. I know exactly what we did not change the position. We must change the position of the memory stream. So right now it keeps on coming back to where it is, because after we have set the byte offset, we go back there and then we recreate this memory stream. You might have to change this and put your code in order, but what we need to do, before we read, for us, we need to change the position of the memory stream and say memory stream dot position is equal to byte offset, so that after we've changed the byte offset, at least it jumps, the read is on the byte offset. Okay, let's stop debugging. And start debugging again. Cool. Let's do this. I just want to get here. Just go to step over. Cool. So we've read the first one. Now we need to go. The position is 24. We should get to the next one. Let's see. The next one is 40. Let's see what box is that. Is 40. Let's see what box is that. UUID. So it's gonna do that until it gets to the end of the file, giving us the boxes that are on the first level. So I'll just do continue. As you can see here, it prints here M dot. It makes sense that M dot would be that, because that's where your data is. That is move. You see, the first one is F type, the second one is UID, which is 40 bytes, is M dot, which is where your data is stored, is 62 something bytes. It makes sense why that one would be so big, because that's where your actual data is. We are going to look at how to get the frames within that box, like how the media players actually play your file, how they get these frames that they display before you, and then they move. It also makes sense why, because a lot of everything about like the samples, the information about the file that you are reading most of it would be there. That's where you're gonna get things like samples, your audio samples, your video samples, which is the pictures that you see, and information when it was created, and all those sort of information. We are going to continue with this course showing you how maybe you can create your own mp4 file reader or explorer that is going to show you the structure of your mp4 file. Let's see what other is done. These are the only on that video, these are the only boxes that are on the first level. Other boxes, these are not the only boxes in the file. These are the boxes that are directly found on the file. So now you know the size of this box, you know the offset, so you can read the bytes from the offset up until to each size, and then get other boxes that are within that box if it's a container box. Does that make sense? We'll see how to do that on the next video. Thank you very much.